This is section 4.1 on probability distributions. I am going to be going through these notes and doing out the examples. So when is a random variable discrete versus it being continuous? So a random variable, let's define that first, is some value x that represents a number value associated with each outcome of a probability experiment. So let me remind you of what a probability experiment is. This could be flipping a coin, seeing how many times you get heads. This could be, here I have a example, the number of rainy days in the month of June. And x would represent, so whatever that random variable is, it's representing the outcomes of an experiment. So did it rain in June or did it not rain in June? So those would be the two possible outcomes, and then x would represent how many times each of the outcomes occurred. So if a random variable is discrete, it has a finite or countable number of possible outcomes that can be listed. So countable numbers are whole numbers, 1, 2, 3, 4, 5, so on. Distinct exact values. So how many pairs of shoes do you own? That would be a countable number. How many days of school do we have? That's a countable number. A continuous random variable is an uncountable number of possible outcomes represented by an interval on the number line. So uncountable means we're including decimals and fractions in our answer. So if you think about how long something takes, it wouldn't just take 1 minute, 2 minute, 3 minute, it could take 3 minutes and 45 seconds. If you think of how much someone weighs might not be an exact counting number. You might weigh 120 pounds, but you also might weigh 120.451 pounds. So those values that include decimals and fractions in their answers, it's not just a countable number, 1, 2, 3, 4, 5, and so on, though that is what we consider continuous. So here we have an example. X is the mass of a random animal selected from the Roger Williams Park Zoo. So since we're talking about weight here, weight can be represented using a decimal. So therefore, this example would be continuous. And another example we could have, so let's say x equals flipping heads. And so this would be discrete. Okay, so this you try, you guys have already done this. There's many that you can come up with. So now to construct a probability distribution chart. Noticing. Okay, so to do this, first we need to determine the frequency. And on your PowerPoint, there were some steps over here. So if you want to have that handy. So the first thing you want to do is add up your total frequencies. So here, my total frequencies, I have X is 1, 2, 3, 4, 5 because it says a recent survey had people rate the new Star Wars movie on a scale of 1 to 5, worst to best. 5 people rated the movie a 1, so that would be my frequency for 1. 13 people rated the movie a 2. 17 people rated the movie a 3. 9 people rated the movie a 4. And 20 people rated the movie a 5. Create a discrete probability distribution of the data. So first we want to total these up. So if we add together 5 plus 13 plus 17 plus 9 plus 20 in our calculator, or you can do it in your head. So here we have 35. Four. So 64 is our total. So now to get P of X, the formula for P of X equals X over the total. So the frequency over the total. So my P of X here is going to be 5 over 64, which equals 5 divided by 64, 0.08. My next one is 13 over 64, which equals 0.20. Next, 17 over 64, which equals 0.227. And then 9 over 64, which equals 0.14. And then 20 over 64, which equals 0.31. And that is how you create a probability distribution chart. So keep in mind, your probability should always be between 0 and 1, and your frequencies come from your word problem, and you need to total them up. Okay, moving on. So now verifying probability distributions, you need to check for two things. The probability adds up to 1, so P of X totals to 1, and each probability is between 0 and 1. So all entries are between 0 and 1. Decide if the distributions are probability distributions. So this first one, all of our probabilities are between 0 and 1. They're all decimals. We don't have any negatives. We don't have any numbers over 1. So now what we need to do is we need to add up these probabilities to make sure they total to 1. So 0.28 plus 0.21 plus 0.43 plus 0.15. This totals, it equals 1.07. So this would not be a probability distribution. Now my next one, so once again, on the notes you took, these were in, so this is 1/2, this is 1/4, this is 5/4. Okay, so here we have 1/2, 1/2, 1/4. Okay, so here, the probability adds up to 1, and it has to be between 0 and 1. Here we have a fraction, 5 over 4. 5 over 4, if we write that as a mixed number, equals 1 and 1/4. That is over 1. So because of this one, all entries have to be between 0 and 1. It is not a probability distribution. So for this one, when we added it up, it didn't equal 1. For this one, there was a number that was not between 0 and 1. So those are the two things. It has to have both. And if it doesn't have both, then it's not. Right, so you can do this on your own, come up with something that is a probability distribution and something that's not. Now, finding the mean of a discrete random variable, the first thing we have to do is we have to sum up. So the symbol for sum up is that little E, all of my x times p of x values. So x is representing the discrete random variable. So here 5, 6, 7, and 8. The probability of x is whatever the probability of getting that is. And then we want to add up, it would be this column. So to get x times p of x, we multiply each one. So 5 times 0.21, we get 1.05. And then 6 times 0.21, 1.26. And then 7 times 0.43, 3.01. And then 8 times 0.15 is 1.2. So now this E means we have to add them all up. So the mean would equal 1.05 plus 1.26 plus 3.01 plus 1.2. Which equals 6.52. And that would be the mean of this discrete random variable. All right, the last thing is expected value. I'm not sure why this didn't come up on here. So expected value is the mean of a random variable, represents what you would expect to happen for many trials to come. So expected value is the same thing as the mean. It's the same thing that we did. Expected value is equal to the mean. So it's equal to summing up x times p of x. So we have to figure out what is x, what is p of x, multiply them together, and then add them all up. So the example that was given, it says, at a raffle, 15,000 tickets are sold at $2 each for 4 prizes. So we're at a raffle, 15,000 tickets are sold. 15, or is it 15? 1,500. So we have 1,500 tickets. And from those tickets, we have a prize of $500, $250, $150, and $75. So $500, $250, $150, and $75. So these are our price totals. Now, when this says gain, this is talking about how much money we got. So if each of the tickets are $2 each for tickets, if we win $500, technically we're not winning $500. Technically we're winning $498 because we already spent $2 on the ticket. If we win $250, technically we are winning $248. If we win $150, technically we're winning $148. And if we win 75, we're winning 73. And then our last possible option is that we don't win at all, and that would mean that we win negative $2. So now, I want to do this in a different color. What is the probability of getting each of these prizes? It says that each of the prizes, so it's only going to be one of the tickets. So if we have 1,500 tickets, the probability that you win this first prize is 1 in the 1,500 tickets. Now, once that $500 prize is picked, now we have a 1 chance, but now we don't have 1,500 tickets anymore. We have 1,499 tickets because one was taken out. Here we have 1,498 tickets. For this one, we have 1,497 tickets. And then here, so whatever's left, so after we pick those 1, 2, 3, 4 tickets, then we have the total that would be left. So this is out of the 1,500. We would have a total of 1,496 tickets left out of the total of 1,500 to start. So then to get our expected value, what we are expected to win, what we're going to do is multiply our gain by our probability. So 1 out of 1,500 is 0.000 times 0.3 zeros and then 667 repeating. So multiply that times 498. Here we get 0.332. For the next one, 1 divided by 1499 times 248, 0.165. Next 148 times 100. So this is 0.099. 1 divided by 14.7 times 73. 0.05 and then -2, so 1496 divided by times -2 would be -1.99. So when we add these all up, we get 0.332 plus 0.165 plus 0.099 plus 0.05 minus 1.99. So your expected value is actually -$3.44. So this is what you are expected to win. So you are not expected to win any of this money. You are actually expected to lose money because it is such a great chance that you are going to pay $2 for a ticket and not win anything.